to Monday's edition of Cracking the Cryptic, where you may remember, if you're a fan of the channel, that a few days ago I solved a puzzle by Star Origami called Michael Palin, which had a whole load of killer cages in the grid, all covered with palindromes, and that puzzle was absolutely beautiful. I loved the logic in it, and I remarked at the time that I'd like to do more Star Origami puzzles. Well, the testers have recommended me this one, which is called Kylo Ren, and apparently this is because this one has sort of killer cages, which use a K and an L, a bit like Kylo, and Renban rules, which are what these purple lines are, and this is meant to be awesome as well. So this is what we're going to be trying, and I'll read you the rules in just a moment. A couple of things to mention first. On the channel earlier today, we released a bonus video of, basically it's Thomas Snyder, the former three-time World Sudoku champion and former World Puzzle champion, speed solving a puzzle called Tapper Sudoku, which is a monstrously difficult puzzle by Serkan Yürekli. Check that video out. It's absolutely amazing to be able to watch Thomas in speed solving mode. I do some commentary over the top of it to try and explain the logic of what's going on, but believe me, it's quite difficult to keep up with the logic when you're going at Thomas pace. For those of you who are not used to Thomas's pace, and few of you will be, and who prefer your puzzle solving more sedate, I have also recorded a solve of that at my own pace, which is available over on Patreon right now. So check that out if you want something a bit more snail-like. Now, other than that, I need to tell you also, on Friday night this week, Mark and I are going to be streaming again. Now, this is part of the Cerebral Puzzle Showcase that's going on Steam over the next few days. We've been allocated a slot in that, so at 10 o'clock UK time on Friday night, we're going to stream for a couple of hours. We haven't yet agreed on what we're going to stream. It's a source of some debate between Mark and I, but I'm sure we will agree sometime soon, and that once I know which game it will be, I will let you know. Other than that, I don't think there's much else to tell you. If you are solving the Patreon monthly reward, you've still got 4 days left to get your solutions to us in order to be eligible to win the prize. So definitely try and do that. It's an equal sums line Sudoku hunt this month, as many of you will know. Now, all that said and done, let's get on with Kylo Ren. Here are the rules. Normal Sudoku rules apply. Digits cannot repeat within a cage, so that's normal sort of rules there. Now, the sum of the digits in a cage is its cage total, and along each purple line, the cage totals form a set of consecutive numbers in any order. So let's just take a look at this sequence of digits here. What that's telling us is these two cells, let's say these, what can I pick that's going to actually work here? Let's make these add up to 15, say. So let's make this a 7 and an 8. Now, this cage, then, well, we have to make sure the cage totals are a sequence. So imagine that this cage added up to 16, this cage added up to 18, and then this cage would have to add up to 17. That could actually work, couldn't it? So if that added up to 17, so we'd have 15, 16, 18, and 17. I don't know if that makes this one break or not, but it's that sort of thing. We need to make sure that the cage totals, rather than the digits, are a consecutive sequence. It's a fascinating idea. Do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And I can't be absurdly snail-paced today because my car needs to be MOT'd in just about an hour. So, where shall we start? We shall start probably with the bottom row, do we? We've got 1, 2, 3, 4, 5 cages in the bottom row, and we can see that we've got one of these purple lines entirely sort of covering the bottom row. So, we now know from the secret that the average value of a cage along this row must be 9. So this must be, in some order, a 7 cage, an 8 cage, a 9 cage, a 10 cage, and an 11 cage. Now, how am I doing that? Am I using magic? No, I'm just using maths, which can sometimes seem like magic, but in this case isn't. any complete row of a Sudoku will contain the digits 1 to 9 once each from the rules of Sudoku. If you add up the digits 1 to 9, you get the number 45. So if we know that the digits here add up to 45, but we know we know there are 5 cages, so we know the average cage value is 9, and so we have to arrange those in a consecutive sequence. So that's how I'm getting to this. 45 divided by 5 is 9, and these two obviously can't be the higher numbered cages, because we're going to have a 10 and an 11 cage here. So these digits have to be from 7, 8 and 9, don't they? Because one of these must be, well, just because they have to be single digit totals, because there's only one cell in their cage. Let me just think about this. Can we do better than that? I feel like we can. There's got to be an 11 cage. There's got to be a 10 cage. Sorry, I'm just not seeing how to do that. I have a feeling I'm being really slow about this. Like the alarm bell in my brain is going off, telling me, think harder, think harder. I'm trying to think harder, brain. I really am. No, I can't see it. I'm sorry. Okay, I'm going to look somewhere else, because that's evading me. We've got an enormously long line here. So this cage here at the top is a 5-cell cage, so that's got to add up to at least 15. That cage is a massive cage. 1, 2, 3, 4, 5, 6, 7. Ah, right, okay, that's going to be putting pressure on things. This is a 7-cell cage. So the triangular number for 7, by which I mean what is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. If you're used to a snooker table, you'll know that there are 15 reds, triangular number for 5. So this cage must add up to at least 28. Yeah, here we go. 28, 24 there, 24, 25, 26, 27. Yes, right. This is where we need to look. Okay, it might not be down here then. It might be here that we're meant to look, because this cage has an absolute maximum size of 24. If I was to put 7, 8, 9 in there, it would add up to 24. This cage has a minimum size of 28. And we've got one cage there that we've not accounted for, one cage here on the line that's not accounted for, and one cage there that's not accounted for. So they must take up the difference between the maximum size of this and the minimum size of this, the 25, the 26, and the 27 cage. So how are we going to notate this? This one is 25, 26, or 27. Same is true of this one. I don't really know if this is sensible to do this. It's almost certainly not, but it's what I'm going to do. This one is 24, so that is 7, 8, 9. This one is 28. Oh, Mark would love this if I did this. Am I going to do it? Am I? Not yet. But we could pencil mark this cage with 1, 2, 3, 4, 5, 6, and 7. But it would seem a little bit overzealous to do that. So, what do we know as a result of this? Oh, maybe. Can we do maths actually on the central box? That's an interesting thought. I know the central box itself. So just those cells, they must add up to 45. But I know this is 24, this is 28, so that's 52. And this one is either 25, 26, or 27. So we're looking at a minimum of 77, which means these cells are a minimum of 77 minus 45, which is 32. That seems very difficult, actually. Is that difficult, or am I going crazy? Because the reason I think that might be difficult is that these 4 cells are all in the same cage of the puzzle. Those 4. Well, the cage of they're all in the 28 cage, so none of them can be that big. The maximum any of these could be would be a 7, because in a 28 cage we can't put 8 and 9. So the maximum size of these is 7654, which is 22. And what did I say I had to get to? 32. Oh, right. So these have to add up to 10 or more. That's not difficult at all. Bother. Right. Sorry. No. Okay. I'm prepared to believe that that was not a sensible. Well, perhaps it was a sensible thought, but I don't think it's actually going to restrict anything here terribly much. Now. Right, so what about 7, 8, 9 in this box then? Because they can't go in there. Well, 7 could, but 8, 9 couldn't. 8, 9 in this box have to be in those 4 cells, because you can't put 8 or 9 in the 28 cage. Now that can be 8 or 9. Can this be 8 or 9? Because we know that the cages along here they're adding up to 7, 8, 9, 10 and 11. Oh, bobbins. Right, that could be 8, couldn't it? There's only one way that this could be that both of these could be the 8 and 9 that we're trying to put in this box. That would have to be 8. Well, no, then the 9 could go up there. Oh, although that can't be higher than 6. 7. That's beautiful. Right, here we go. Here we go. This is where we should have looked. Right. In box 8, where do 8 and 9 go? 8 and 9 can't be in any of the blue squares by Sudoku and the fact that we can't have an 8 or a 9 in the 28 cage. So the 8 and the 9 in this box are in 2 of these 4 cells. But this cell has a maximum value of 6, which means this cage has a maximum value of 8. So if we were to put 8 into it, or 9, it would obviously be greater than that. So we cannot put 8 or 9 in this cage, so in effect they become blue, which means this is an 8-9 pair. And I can't, this is it, right. So now, this is an 8-9 pair, but let's think harder about this. Can we put 9 in a 3-cell cage? Well, even if we accompany 9 with 1 and 2, it will add up to 12, which is too high, because we know the maximum cage size we can have along the bottom row is 11. So I think we get 2 digits. No, 3 digits. We get 8, 9, and 7 in the corner. Oh, and this must be a 1-2 pair. And these cells now have to be the other digits, which are 3, 4, 5, and 6. And the cage values over here are, so we've had 7, we've had 9, and we've had 11. So we've had the odd, so we need 2 even numbers in between. So we need 8 and 10. Right, okay, so one of these is 4, 6, one of these is 3, 5. But I don't know if we can learn the order of those. Right, maybe, this is going to get really complicated now, because what I want to do, I'm going to do it, is I'm going to pencil mark 9s here and 8s here. And I've got to almost ignore these 25, 26, 27 markings, because that's just telling me the sizes of cages. This is a maximum of 6. So the maximum size of this cage is 8. 14, 31. No, okay. Let me think about this. How do we do this? Do we get... sorry, I realise I'm totally blanking here. I've got nothing really jumping out at me at all. It's weird having to sort of scan this. I feel that we've got to use the digits we actually know. So how do we do that? I know there's a 9 in this cage up here, but this has a very high total. If there was an 8 in the cage as well, that would be totally reasonable. Sorry. I'm just not seeing it. Get rid of the highlighting. Get rid of the highlighting. And think harder, Simon. Come on. This box, I know the total. Well, I know that these 3 cells have 3 possible totals, don't they? Because these 6 cells either add up to 25, 26 or 27. So these 3 cells, in order to make sure the box adds up to 45, are either 18, 19 or 20. Okay, so this is 18, 19 or 20. Do I have a way of recording that? 18. I can do 18 and 19. 20 is not going to work. The 0 is going to go first. But I will remember that this is just the wrong way round. So these cells, therefore, have to be... Oh, hang on. That's got to be quite high. Ah, this might be where we're meant to look now. What is the possible sizes of this cage? Because even if this is minimum, if this is 18, this can't be less than 16 because there's only 3 cages on this line. So this is at least 16. So this is 7, 8 or 9, and it definitely has a 9 in it, which means that is not a 9. Aha. Aha. Okay. So if this was 16, this would be 17. That's 33. So these would add up to 12. And this would be, I want to say that would be odd. That must be right, mustn't it? If you know, yeah, these 2 cages, well, no, the line here contains consecutive sums. So if you add up 2 consecutive numbers, you always get an odd number. So this string of digits adds up to an odd number overall. So if they're even, that's odd. I'm going to make that orange to remind me of this. This is 1. Okay, this is actually 1, 3 or 5. 1, 3 or 5. Oh no, this is wrong. This is wrong. No, this is wrong, because this is all on the presumption that this is 16 and this is 17. That might be total gibberish. Sorry. Right, let's get rid of this. If this is not 16, it has to be 17. Yeah, it has to be 17. And then that could be 18, 17, 18. That could be 16. Oh, bobbins. No, that doesn't work then. If that's 17... Oh, hang on. If that's 17... I'm trying to work out if this sequence of digits is always odd. If that's 17... If this is 16, that is 18. And this is definitely 17. But if this is 18... Sorry, if this is 17, it can't be 18. If this is 17, this can never be 20. This can never be 20. That's one thing we can say. That can never be 20. So this, that's because this can never be higher than 17. So if that can never be 20, this can never be 25. Aha. Okay, and if that's 17 and that's 18, this has the option of being 19 or 16. So it has both possible parities, and that means that we don't know what the parity of those three is, and therefore I don't know what the parity of that is. So this has been a total wild goose chase. Although I have learned slightly more about the possible values of these. If this is 19, that has to be 17, and this has to be 18. But if this is the problem one, is if this is 18. If this is 18, this has two possible values, and this has lots of possible values. Right, okay, let's try something else. What can we try? We know that this is 1, 2, 3, 4, 5, 6, 7, don't we? Yes, we do. We know that this one is, we don't know, we almost know nothing about this one, do we? We know, that's an interesting point. Where does that digit, let's make this a yellow digit, where does that digit, which is not a 2 or 5, that's a possible cage total, where does that digit go in this box? Because that digit can't go in here by Sudoku, can't repeat in its cage, so it's not in there, so it's in one of these cells. And then it can't, because it's already in this cage, it can't repeat in this cage, so it can't go there. So by Sudoku, obviously, this digit has to be in one of those cells. Well, it's not 9, because 9 is already looking at yellow. It's not here because it would repeat within its cage, so it goes there. That's very, very, very underwhelming. Can we do something with that? Do I know what this is? I suppose I know it's not. I know it's a reasonably low digit. It's a 1, 2, 3, 4, 5, or 6. Oh, actually, maybe the point is not this cell. Maybe the point is this cell. Because actually, let's just have a quick look at this cage. Because this cage, most of its digits C, 7, 8, and 9. And yet it has to add up to at least 25. So we can put one high digit in this cage, and we can't. Oh, okay. We can't put 9 in this cage at all, just because of Sudoku. But if we want to put 7 or 8 in, it has to go there. And if we don't put 7 or 8 in, surely it can't add up to enough. 6 plus 5 plus 4 plus 3 plus 2 is 20. That's most certainly less than 25. So this digit, which is the only place in this L pentomino that I can put a 7, 8 or 9 in, that digit has to be a 7 or an 8. Okay, so we're going to have to get rid of our pencil marks here. I think I'm going to have to get rid of this because it's going to be too confusing. This, oh look, I've got a 7, 8, 9 triple in this row. So these three cells now have a maximum value of 15, if they were 6, 5, and 4, and that, well, that's very annoying because that's an extremely average number. You can see that 3 15s would get us to 45, but we could make these lower. In fact, because we've got a bit of leeway here, we could go 15, 14, 12, and 13 here. And that's, you know, that's on the presumption that this is all high. This doesn't have to be high. Maybe that's the thought. Maybe this can't be too low. If this was adding up to, say, 10, 11, 12, 13. No, that's actually the limit. The limit here is 10. If this is 10, you can't make box 3 add up to enough. 10. I can make this 11. I can make these a maximum of 12 and 13, which is 25, 35. That would have to be a 10. So these three digits add up to 11, 12, 13, 14, or 15. I don't even have enough cells in the cage to pencil mark all of that. All right, let's come back to this one. This one has one digit from 7 and 8 in it. And the maximum these other 4 digits could be are therefore 6, 5, 4, 3, which is 18. So this is important because we've not got many degrees of freedom here. So if we max out every possible cell in this L pentomino, we'd have 8, 6, 5, 4, 3, which is 26. And we know that this cage has to add up to at least 25. So this is, well, it must have 6, 5, and 4 in it. There must be 6, 5, and 4 in these squares, and then either 2 or 3 as the last digit. It can't have a 1 in it, so there's a 1 in one of those cells. Wow, right, okay. So, what does this mean? The answer to that is I don't know. No, I do know. Oh, that's just beautiful. Good. Star Origami is really, really good at making these Sudokus. Where does 1 go in this box? I was looking at that then, thinking, I wonder if it matters that the 1's not in here. And then I stared at it for a bit and thought, no, I can't see anything. But I've just realised that I should use my yellow highlighting. This digit can't be a 1, because it must be the same as that digit, which is not a 1. So this digit is 2, 3, 4, 5, and 6. And now we ask where 1 goes in this box. It can't repeat in the cage, so it's not in any of these cells. And it can't go there, because if that's a 1, one of these has to add up to 2, and that won't work. So it must go there, I think, which means that there's a 1 in one of these. Oh, I was about to get very excited, because I was thinking this was a 1-8 pair, but no, this could be the 8, couldn't it? But there is a 1 in this cage, and this cage is either 25. So this is definitely 2 of this cage's cells add up to 10, because there are a 9 and a 1. We're almost getting to a point where I'm quite interested in pencil marking everything. I know I don't normally do it, but I just sort of feel like there's got to be hang on, what's going on there? That's a problem. Oh, this is obvious. Right. Okay. Right, this cell is where I want to look now. Whoa, have I chosen the wrong colour? Maybe. Let's choose orange. Where does orange go by sort of Sudoku stroke nonsenses in this box? We can apply the power of nonsenses because orange can't go in those 3 cells, and orange can't repeat within its cage. So orange in this box is in one of those cells. But by the same token, we know orange is in the 28 cage and cannot be 8 or 9, so that is a 7. And that means that this is an 8. And that means that 7 has found a home in our sort of comma-shaped region at the top. So does that mean we can't put the 8 in there now? Because then we'd have 9, 8, 7, 1, which is 24. Oh, but we could have a 2 in here, and that would work. Ah, you rotten thing. Let me think about this. Sorry. There is definitely a 1 in here. I know this is 8 now, so unfortunately that does allow us to use either 6543 or 6542 in this cage. Oh, maths. Maths. Oh no, not maths. Well, there's something going on in this column, because remember we know that the total for this this L pentomino is either 25 or 26, but this cell is transposed into this position, so therefore I know those 5 cells together add up to 25 or 26. Now 9 plus 7 is 16, so that means these 7 cells add up to 41 or 42, which means that these 2 cells don't have an 8 in, which we already knew, but they are either they're either a 1-2 pair or they're a 1-3 pair, and I think therefore we've got to dispense with our 25, 27 pencil marks here. This is 1-2 or 1-3. Can we get more of a grip on things than that? Possibly. I don't know how. Although, yeah, that doesn't work. Right. Okay. Where does 2 go in this column? Not here. If we put 2 there, we'd have to make one of these add up to 3, and we can't do that because the 2 isn't available. So that's not a 2. So I think 2 in this column has to be at the top. And if that's the case, this has to be a 1-3 pair. And if that's the case, if that's the case, I can't put 3 in my L pentomino. So this is, now we know the total of this. It's got to be 25. So this is 25. Oh, that's a bit annoying. But now we can limit this one, because we know this one has got cells that sum to 20 in it. Oh, this is it. Right, this is really beautiful. Okay, so what does this cage add up to? And the answer is, well, the answer is either 26 or 27, because we found the 25 cage, this is the 24 cage, and this is the 28 cage. So we're either looking at 26 or 27. To make this cage add up to 27 would require a second 7 in it, I think, because it's already got digits in it that add up to 20, including a 7. So this must add up to 26, which means there's a 6 in one of these cells. So this is now 6, 7, 9. That square is not 7 or 9, so that square is 6. This is a 7, 9 pair, and I'm sure this is going to be important somehow, that we can take 6s out of these. We can take 3 out of this one, so we can... And now we know what this one adds up to, don't we? Because we know this is 26, so this is 27, and this is therefore 18. So what does that mean? So if this is 8, oh, that's the one we didn't want. That's the one we didn't want, because this can still be 16 or 17. That means, oh no, hang on. No, we've got an 8 here, so this is 16. Oh, that's better. Right, that's better. If this is 16, and this is 18, this is 17. So if that's 17 and that's 16, these are 33. Now my parity trick works. These have to add up to 12, which means this has to be an odd number, because these 3 are even, and we know in total those 4 cells are odd. So that is odd, and it's, that is sick. That's 5. That is absolutely filthy, because because it can't be 1, 3, 7 or 9. Isn't that beautiful? That is really beautiful. So that's not 5 now, so that's not 5. If I Sudoku, this square is a 2 or a 4. Now, have we really done damage now, or are we? Well, okay, hang on. We can do some stuff at the bottom here, can't we? That can't be 5, and it can't be 4, so this is 3 or 6. I have a lot of difficulty believing this can be 3, but let's check that out. If this was 3, this would have to be 3, 4, 5 triple. So this would be 3. No, that's impossible. Neither. If this is 3, neither of these could add up to 4 because they'd have to be a 1, 3 pair. So this has to be 6. This has to be 3. This has to be 5 to add up to 8 because we know that we had one of these had to add up to 10, and that's going to have to be 4, 6. Now what does so this one? This one's definitely adding up to an odd number because, oh no, that's not true. I keep getting this. It's very easy to make a mistake with this puzzle because no, this could be even if that's odd. So we need, what do we need here? We need 2, 4 and 5. Oh, but okay, but no, that's good enough. That's good enough because now this cannot be even, because if it's even, that adds up to 6 and that adds up to 6, so that is 5. And this 2, 4 is a real 2 or 4, it's not a total. In fact, I'm going to get rid of my 28 total. I think that's asking for trouble. So these two are the same, mustn't forget that. So there's a virtual 2, 4 pair in this column now, which is obvious because we just, well, we know there's a 3 in one of these cells. Because there must be a 3 in this box. Okay, right, let's do maths then. This can't be 4, can it? Because that would be 9, and that's definitely too far away from 6. So that's 2, that's 4, and now we know what these 3 digits are. Sorry, I should have seen that all instantly, but I'm getting discombobulated. Right, this is 2 now, because we know those two are the same digit. Therefore, that's a 4. And okay, so if this is 7 and 6, this is either 8 or 5. Oh, bother. Well, it's not 5 actually, because it can't have 2, 3 and it can't have 1, 4. So it is 8, and it can't be 5, 3 or 2, 6, so it's 1, 7, which is quite cute. So this is 1, 7. I'm going to move that 27 there so it looks a bit more symmetrical. This is 18. And I realise I should know what this means, but I don't. What can I do with that? I know what those 2 digits are now, because they must be the balance of the 28 cage. They must be a 5, 6 pair. Oh, it doesn't do anything. That's rotten, isn't it? Okay. What about these digits then, maybe? Yeah, okay, because we haven't looked at these for a while. We need 1s, 3s, 4s, and 5s into these cells. That's going to be troubling, isn't it, for this? Because we know that this had to add up to at least 11 from the work we did earlier. That's it. That's beautiful. That's absolutely beautiful. Right, so how do we make these add up to at least 11? Well, they must be. They must take all the high digits, because otherwise 5 plus 4 plus 1 is only 10, and when we did the maths on that, it didn't work. No, it doesn't work. 10, 11 there, so the maximum you make those is 25 with a 12, 13, and it doesn't, you have to put a 10 in here. So this is 3, 4, 5, this is 1. Now, therefore that's not 5 by Sudoku because it sees this 5, 6 pair. So if this is 12, we probably need to make these bigger, don't we? If we made... So if we made that 13 and this 14 and 15, oh no, okay, this doesn't really do anything. So I think this has to be at, oh, maybe it has to be at least 6 then. Let's just check the maths on that. So if we try and max it, I'm going to try and max out the value of the cages in box 3. So I've got 12 here. I can allocate the 13 here rather than to one of these. So I'm going to make that 13, 14, 15. So those add up to 29, these are 12, that's 41. So this has to be at least a 4, which it can't be, there's already a 4 in here. So this has to be at least 6, and it can't be 7. So that's 6, 8, 9 in the corner. Which I don't think is going to be good enough, is it? What do these 3 digits add up to? We know that this was 16, this was, oh, these are 70, right, so these 3 digits add up to 16, and we're not allowed to use 7 or 9, so do we have to have 8? Yes. Yes, we do, because 6, 5 and 4 only add up to 15, so there is an 8 in one of these. So we've now got 9, and we need another 7. Oh, hang on, is that right? No, I need another 8. I need another 8. I was deducting the 1 twice, that's not sensible. Let me just double check this. This is adding up. These 3 are adding up to 16, that's the point. So I've got an 8 in one of them, so I need 2 more to add up to 8. That 4 is very unhelpful. So all we know is that this is either 2, 6, 8 or 3, 5, 8. Oh no, we do. There's a 5 in this box, so that's 3, 5, 8. That's lovely. Okay, so now these cells have got to be 2, 4, 2, 4, and 6, I think. Which and that makes sense because we knew those 3 added up to 12. Finally, we're getting somewhere. Right, this is now 3. This is now 1 by Sudoku. 1 lives in this cage up here. They're aligning. Look. In columns 7 and 8, so there must be a 1 in one of those 3 cells. Closing in on MOT time. I need to hurry up. Hurry up, Simon. Figure out the puzzle. We've got to make these consecutive, don't we? So that can't be 6, because then that wouldn't add up to enough, so that's not 6. If that's a 2, we've got 7 here. No, 7 and 10, that doesn't work, so it must be... Yes, it's 9 and 8, I see. So that's 4. And this is a 2, 6 pair. And that's very annoying. Look, that doesn't do anything. Well, it puts a 6 in one of these cells. This can't be a 5 by Sudoku. It's actually really a bit disturbing, this, how little we know about this part of the grid. And I don't really, in fact, it really is weird. I think there's something I'm not understanding about. Maybe that 18 cage is restricted in a way I don't understand. 2, 6 here takes 6 out of the corner, so this is 8 or 9 now. Can we do something better than that? There's got to be an 8 in one of these cells. I'm not seeing anything brilliant here. 6s have got to be in one of those 3 cells. Wow. Wow. I can't see. Oh, that's not 6, I suppose. Okay. Oh no. Okay, that might be interesting. So 6 is definitely in this domino, where we've got to accompany it with a digit that gets it up reasonably high. We've got 12 here. Problem is, it's got so many options, this. What's the lowest it could be? Well, in theory, it could be 9. But I think that's going to break the... So 9, 10, 11, 12 or something like that. But if that was 9, 21, we'll make that 11, 32. That doesn't get us anywhere near, actually. So this is more than 9. And so actually this has got a high digit with it, because it can't therefore have 3, 4 or 5. So it must be a 6 with a 7, 8 or a 9. And that's not 7. It's so close to being a triple, isn't it? That's my reminder about my MOT. Go on. Oh, okay, but there's no 8 in there either. Hang on. Oh, it's so close. Yeah, okay, look, I've now got a 6, 7, 9 triple in this row. So that means this cell is a 2. Oh, that's good. That gets me a 2 and a 1. Whoa. 2 and a 1. That might place 1 here. Right, so it's going to be this cell, isn't it? This cell by Sudoku is 7, 8 or 9. Now, what are the exact options here? If there's a... Oh, hang on, how could that have a 9? Oh, no, maybe it can. No, it can't now. Hang on. There's too much tension here. We've got... This is maxing out... No, this can't be 12, because then it would add up to the same as this. So this is a maximum of 11. So yeah, how could this be 6, 9? That would be 15. And 15 and 12 would need the other digit, the other cages here, to be the 13 and the 14 cage. And this can never be that high. So this is not 6, 9. So it must be 6, 7, and we can see the order. This is really beautiful. So that becomes 8. That's a 9 in the corner. Now we have to hope the maths works. We've got 13 and 11 is 24, 36, 9 is 45. So the maths does work. And we've got a 12, 13, 11. Sorry, is that really true? Yeah, we've got 11, 12, 13. I don't believe it. So this is either a 10 cage or oh, this is beautiful. Oh, so this cage is either a 14 cage, which it's not, because there's 5 and 6 aren't available. So it's not that. So it must be a 10 cage. This was 11, wasn't it? So this is a 10 cage. I don't have a very good way of notating that, because the 0 will go the wrong way round. But I'm going to put that in anyway, just so I can try and recall to myself that's what's going on. Right, I can probably risk another 3 or 4 minutes. Let's see if we can just crack this. Come on. It's going to be all around this one, I think. I'm just not quite sure how. I suppose this column is restricted now. We need 3, 4, 7 and 9. Yeah, that square's a bit restricted. So that can only be 3 or 9. That's 3, 4 or 9. Yes, okay, where does 7 go in this column? That's a sensible question. It goes here. Do we know anything about this? We probably do. 3, 4, 8 and 9. Oh, hang on, this is now getting strange. That suggests I know what these digits are, because that looks like a 3, 4, 8, 9 quad. How could that be true? That would mean this was a 5, 6 pair. Yes, it is. It is a 5, 6 pair by Sudoku. Good grief. Okay, that feels important. So it really depends what the possible values of this Oh. I mean, if that's... so the thing is, there seems to be quite a lot of optionality here. If I knew what this digit was, 1 looks like it's trying to poke its way into here. If this was 12, this would have to be... Oh, that could be 13 or 11. Okay, that looks quite reasonable. But the problem is this could be 17, and then this could be something like 15, and this could be 16. So it's far from clear what's going on. Okay, this is a 10 cage, isn't it? It's now not 4, 6 or 3, 7. So it's either 2, 8, which very specifically would be that way around, or 1, 9. But why do I not think? Why have I not got the 1 in this cell? No, this is me messing about with pencil marks, isn't it? That can be a 1, that's the problem. Bother. So it's either 2, 8, so it's either 1 or 2 here, or 8, 9 in here. Was there a reason I didn't have the 1 in this cell? I don't see it. I think the 1 could have always been here. I think that's just... It probably was in there and I just deleted it by accident. But that doesn't help me, does it? That's just... right, this is not 9. So this is 3, 4 or 8. Three, 4, 8, 9 here. It's really strange, this, because there must be some way that we're going to be able to disambiguate this whole left side of the grid. It looks very, very difficult to me to do that, unless this 18 cage is somehow magical in a way I'm not appreciating. Right, that's not a 4. There's a 4 here. So there is a 4 over here. There is a 9 in one. There's a 9 because this is a 3, 4, 9 triple. The 9 is here, so this is not 9. Okay, all right. So can this actually be 7? No. Right. So there must be an. Well, we can see it actually from Sudoku. There's an 8 in one of these. So this is either 12 or 11. So this square here is not 8 anymore. So if this was 12, so this digit can't be a massive digit, can it? Maybe that's the point. If this is 11, this is already adding up to 11, so this could be a maximum of 3. If this is 12 and this is 11, can we make that higher than... Hang on, I'm getting confused now. 12... This could be 13, this could be 14, so I think this could be 3. I'm not sure it can be any higher than that. If this is 4, this is 15. Yeah, that's too far away. Okay, so this is 1, 2, or 3. That's so annoying. That is so annoying. Okay, so this can't... No, the point is this can't be 9 then. That would be 16, and the 1 is over here, so we'd be up to at least 18 for this, and that's too many. So this is 3. Ah, there we go. There we go. That's what I should have spotted. So now this is 9. That's getting me a 3 over here. That's getting me a 12 total here. So this has to be not 12. So this can't be the 1. So if this is 3 now, we've got 14, and this has to be 13, which it can't be. That would repeat the 3. Let me just double check that. 12. If this is 3, that's 14. So this would have to be 13 to make the line consecutive, and we'd repeat the 3. So that has to be 2, which makes this 13, this 12. So this could be 11. It can't be 11. So it's got to be I'm getting confused again. 12, it's got to be 14. This has got to be a 4. So that does my 4 and my 8. That places 4 up here, which I think was already placed. So now, now I get my 6 and my 5 done. Now I get my 5 and my 3 done. I get my 1 here, which means that's a 9. We know that had to add up to 10. And these two squares now have to be 3 and 8, which is also resolved. Now, how does this get resolved over on this side of the grid? I'm actually rather worried about this. 4 comes out of here, 2 comes out of here, 1 comes out of here, 3 comes out of here. And somehow, some way, it doesn't do enough, does it? Oh, this 1's doing something I haven't spotted. That gives me a 1 and a 7. Oh, that's it. There we go. That's what we've been missing. I didn't understand the restriction that was on this 18 cage, but now I do. It's got a 1 in it, so it's 189. And now, and now we know some digits. So we definitely went about that the hard way. So this is 9, this is 7. That's now 7 by Sudoku. That's 9, that's 8. Come on. I'm going to get rid of that 27 before it trips me up. I am going to say that... How is this not done now? Oh, what are these digits then? These have got to be 2, 8 and 9. So that's a 2. That's a 2, that's a 6, that's a 6, that's a 4. And that square's a 5. These squares here have got to be 8 and 9, which is resolved. 9, 8. That gets me the 8 and the 3. So now I think we're cooking with gas. We need 2, 3 and 6 here. Let's put them all in. 2, 3 bobbins. And this has got to be 4, 5 and 7. And we can get this one, which will hopefully do some work. Yeah, here we go. 7, 4, 5, 4, 5, 6. And I've got a 2, 3 pair here. That's no use at all. The 9 and the 1 are resolved, which gives me the 2, 3, the 1. That gets me the 2, the 6 and the 3. The 7 and the 9 are resolved, and that is one heck of a beautiful puzzle. I've just got in terms of my time. I'm going to have to stop now. I'm really sorry. Kylo Ren has been defeated, or is that... Yes. Yeah, I think Kylo Ren has been defeated. Well, who would I be in the Star Wars saga? I better not say anything in case people haven't seen it and I spoil anything. But anyway, Star Origami, absolutely brilliant again. Fabulous, fabulous puzzle. Tricky. I did not get to grips with that with any sort of aplomb, but I hope you'll forgive me. I look forward to the comments, which I do enjoy, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.